Hello and welcome back to Gaffy's Grinds. My name is Mr. Gaffy and I'm a Leave Cert chemistry teacher. In these videos we take concepts from the course, we break them down into simple manageable chunks and we give you guys some practice to do. Now the practice part of the videos is what makes our videos different from most other videos. We don't just fly through content, speak a load of stuff and expect you guys to remember it all. We actually break it down and give you enough opportunity to practice it and master the information. So if you're going to choose these videos, they're a bit longer than other videos, but they will help you to learn it better. So if you're not going to actually do the questions when I ask you to, then you really should just go and watch a quicker video that'll just fly through it. But I don't think you're going to learn it and remember it for as long by doing that. So if you want to learn it, have it stick with you and really master it, stay here, but make sure that you make sure that you practice all the questions properly. Now this is video 2 in our series on quantitative chemistry, where we talk about how we can describe chemistry and describe things using numbers. So in our previous video, we looked at something called the MR, which was what we call the relative formula mass. And in this video, we're going to expand a little bit on that. Now, I'm going to do something I don't normally do, and that is I'm going to not explain something fully until the next lesson. Now, there's a really good reason for this, okay? So you may not fully understand everything that I do today, but I'm hoping you'll be able to follow me pretty closely. But you may have a few questions burning in your mind going, why is that? How does that work? And I promise, hopefully by the end of the next video, you will understand it fully. We're going to start off by talking about an analogy that we have with something that we use in everyday life, and that is where we use words for numbers. So an example is if we take this word, dozen. The word dozen, most of us will know, means the number 12. Other similar words that we have include like a pair. So a pair is 2. Sometimes we have a score. This is 20. So if you got a score, that would be a pretty common slang word for someone got a €20 note for you. If you got a score, a ton would be 100. And then if you're from England, Cockney rhyming slang that they talk about in England, in London, you would refer to a monkey. If you got a monkey, which would be 1,000. So £1,000, for example, would be a monkey. Now, of course, some of these are more commonly used than others, but dozen is a pretty commonly used example of this. Okay, the reason where this came from is that eggs come in crates, and it suits the sizes of eggs to come in 6s or 12s. Okay, so that's where the word dozen came from, because the boxes of eggs were in 6s or 12s. Now, we can manipulate this dozen to mean, like, if we say, a half dozen. If we say a half dozen, we would be talking about 6 eggs. Half dozen would be half times the 12, would be 0.5 times the 12, which would be 6. You could have 2 dozen, and this would be 2 times the 12, which would be 24 eggs. You could have 10 dozen, which would be 10 times the 12, which is 120. You get the picture, I hope. It's just a word that represents a number. It's not scary. It's not threatening. Well, in chemistry, we also have a word that means a number. So just like we have the word dozen, that means 12, in chemistry, we have this word mole, M-O-L-E, mole. And mole is just a number. What happens to be a very, very, very large number. So that's the big difference here. A very, very large number. That number is equal to 6.02 times 10 to the power of 23. And that is a very, very large number. And I'm not going to explain to you where this number comes from right now. This is the bit that I'm not going to explain at the moment, but I will in the next lesson. Okay, so you're just going to have to stick with me on that. So all you need to be able to do for now is you need to be able to use this number. So if we take, for example, before we do an example, I just want to see that we can all use this number, put this number into our calculator. Okay, so let's get our calculator out now. I'm guessing you will all be using this model of calculator here. Okay, most of us have this model of calculator. Nearly every school in Ireland has this model of calculator, or a very similar one. Okay, now we're just going to practice putting this number into the calculator for now, just that number, 6.02 times 10 to the 23, the mole number. Okay, so let's begin by putting this in. Okay, this is the first part. This bit should be easy for everyone. 6.02. So let's put that into your screen first. And you should get 6.02, like that. The next bit, I suppose, is the hard bit. And it's not really very hard. I mean, it's pretty simple stuff. But it's this button, x 10x, so by 10 to the power of. And it's down here beside the answer button. So just down here at the bottom, beside the answer button, you'll see the x 10x button, by 10 to the power of. So you press that button and you'll get like this here, 10 to the something. Then you're going to put in the power, which is 23, by 10 to the power of 23, like this. So you should all practice just putting that number into your calculator. Okay, that's what you should do. Okay. Now, just for clarity, if we wanted to know how big this number was, it's 6. But we don't, if we want to know the full size of this number, I wouldn't write the decimal point here. What I need to do is, because this is by 10 to the power of 23, I need to move this decimal place 23 places to the right. So it's going to be like 602 and then 21 more zeros after it. So look how long this is going to be. How many zeros is that? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We'll do the same again underneath. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and an extra one for good measure. It's that many zeros. Crazy, crazy, crazy big number. I don't even know the name for that number. It's so big. Okay, there's like, there's millions, billions. I don't think there's a name for this number. Okay, so it's a crazy amount. But all I want you to be able to do right now is put that in your calculator. So I'm hoping you were able to do that. All right, let's go back here. I'm going to do a little example. Okay, so remember, if I have 1 dozen eggs, that means I've got 12 eggs. 2 dozen eggs is equal to, well, you probably know that's 24 eggs. But what is the process going on in your brain that's doing that automatically? This is what you're really doing. You're taking the 1 dozen, which was 12, and you're multiplying it by 2. 2 times 12 equals 24. Well, it's the same idea that if we have 1 mole of eggs, that means we have 6.02 times 10 to the power of 23 eggs. So we can have a mole of eggs. Now, technically, I'm pretty sure you couldn't really have a mole of eggs, because I'm pretty sure that that's more than the amount of eggs that's ever existed in history of chickens. But technically, you could count a mole of eggs. What if we had 2 moles of eggs? Well, then we take our number for 1 mole of eggs, 6.02 by 10 to the power of 23 eggs. And the same as what we did up here, we multiply it by 2. Okay, so put that into your calculator now, do that calculation. 2 by 6 by 10 to the 23 eggs. Let's do that. So put that into your calculator. So I'm going to go ahead. I'm just going to stop talking for about 20 seconds and give you a chance to put that in. Okay, this is what you should have got. I'm hoping. If you didn't already, if you need more time, pause the video. Okay, so you should only be listening to my voice if you have an answer now. I'm hoping that you got this number when you did this. 1.204 times 10, and it's not 23 anymore. It's now gone to the 24 eggs. Okay, so well done if you got that right. Now that's obviously an enormously, impossibly large number of eggs. We don't really use a mole for counting eggs because eggs are much bigger than the thing we count with moles. Okay, it's pretty easy. I'm hoping it's pretty straightforward. It's the same as 1 dozen is if you want 2 dozen, you multiply the 12 by 2. If you want 2 moles, you multiply the number of moles, which is 6.02 by 10 to the 23 by 2. Okay, it really is that simple. Okay, let's talk though about something that we don't count eggs in moles. We count things like atoms and electrons and protons because these things are impossibly tiny. And we really do have this many of these things because they are so small. So if we say we had 1 mole of electrons, electrons are positively charged particles that we find inside atoms. If we had 1 mole of electrons, that would mean I have 6.02 times 10 to the power of 23 electrons. What about if I had 3 moles of electrons? How many would I have then? Well, I would have 3 times 6.02 by 10 to the 23 electrons. Because remember, this was 1 mole. And if I have 3 of them, then I take my 1 mole and multiply it by 3. Easy peasy, right? Okay, so let's do that on a calculator. So pause the video, get your answer on the calculator now, please. Okay, I'm hoping that you got this 1.806 by 10 to the power of 24 electrons. Now, if you're not getting this number, you're doing something wrong on the calculator. So go back in the video where I talked about how to put the number into the calculator and watch that bit again and try it again till you get this answer. So you should be getting this answer. If you're not, that means you're doing something wrong on the calculator. What about if I had 0.8 moles of atoms? It really doesn't matter whether we're counting atoms or electrons or protons or neutrons. These are all tiny particles. It doesn't matter. The process of working out how many there are going to be the same. All right, so I'm going to stop now and I'm going to get you to pause the video. I'm going to get you to do the whole sum for me. Okay, so you pause the video and do that for me now, please. Okay, so this is how we should have done it. So you should only be listening to my voice if you have done this. So you should have 0.8 times the mole number, which is 6.02 times 10 to the power of 23. And this is going to be atoms. When we put that in the calculator, you're going to get 4.816 by 10 to the power of 23. And don't forget to write atoms at the end. That is how many atoms we have when we have 0.8 moles. Okay, now notice that this number, 4.816, is less than 6.02 by 10 to the 23. So both of these are the same. By 10 to the 23 is the same, but this number, 4.816, is smaller than this number. And that makes sense because I don't have a full mole. I have only 0.8 of a mole. So that makes sense. So that's another clue that this is correct. Okay. What about this one? 17.6 moles of molecules. I want you to pause the video and answer that one for me now, please. Okay, so what you should have done is you should have taken your 6.02 times 10 to the power of 23, which is the 1 mole number, this is 1 mole, and multiplied that by 17.6 because you've got 17.6 moles. And when you put that on your calculator, you should have got 1.05952 times 10 to the 25. Okay, so that's what you should have got. All right. And again, if you're not getting that, you're doing something wrong on the calculator. So you need to pause the video and go back and watch how to do it on the calculator. If not, then you need to leave me a comment down below and ask me what's going wrong. Tell me what's happening and I can maybe try and explain it in another video. Okay, so what I want you guys to do now is I've got some practice for you guys to do by yourselves. And here are questions, please. What would you like you to practice them for me? Okay, so you should only watch the video if you have answered each of those. Right, 1 mole of atoms, 2 moles of atoms, 7 moles of atoms, all of those should be pretty easy. Okay, so you take the mole number, 6.02 by 10 to the 23, and you multiply it by 1. Then in the second one, you multiply it by 2, and then the third one, you multiply it by 7. Those are pretty easy. I'm going to show you the answers in a second. In the next one, you take your mole number, 6.02 by 10 to the 23, and you multiply by either half or 0.5. Both of those will do the same thing for you. So that will give you an answer. And then the last one, just to be clear, if you didn't know, a dozen is 12 and a score is 20. So if you weren't sure of that already and you haven't got those in your sums, then pause the video and fix them now. All right, here are the answers. Okay, so you should either be ticking them or you should be fixing them. Okay, so tick them with a red pen or fix them for me now, please. Do that. Thank you. Okay, now, so this number is this 6.02 times 10 to the 23 is a really important number for chemists. And it was a guy called Avogadro that discovered this number. Okay, and we're going to see more in the next video where this number came from and why it's so important. Okay, but know that it's called Avogadro's number. Avogadro's number. So far I've been calling it the mole number. Okay, but it's really called Avogadro's number, or sometimes it's called the Avogadro constant. And constant just means never changes. And again, it'll make more sense in the next video when we actually figure out why is this constant. But know that it's called the Avogadro's number because he was the person who discovered it. Now, I hate just saying that this is a number, learn its name, but it just doesn't suit. It doesn't work properly to stop and explain all that here. It works better in the next video. So do just bear with me for now. Know that that's what I've been calling this mole number, or the mole, this number that's a mole, is actually called Avogadro's number. Now, I want to try a different kind of task with you now in a second. But before I do, we're going to need to recap something. And that is we're going to have to do a quick recap of an atomic structure. Atomic structure. You know, atomic structure refers to what actually makes up an atom. So, very quickly, if I was to draw the general outline for an atom, in an atom, we generally tend to find in the center what we call an area called the nucleus. And in the nucleus, there are 2 types of particle. So I'm hoping that you guys remember from junior cert or some chemistry you've already done, what 2 particles or the names of 2 particles we find in the nucleus. What are the names of those 2 particles? So on 3, I want you to speak your answer out loud to the screen. 1, 2, 3. Okay, I'm hoping that you said in the nucleus, we find protons and neutrons. Protons and neutrons are found in the nucleus. And then outside, on these rings that I've drawn, these circles, these are what we call energy levels. And out here, we have electrons. So we find these electrons, which I'm going to draw in blue. So blue X's here. So electrons are found. We describe them as, these are electrons, and we describe them as orbiting the nucleus. And orbiting basically refers to moving around in a curved path. Okay, so orbiting the nucleus. So we have 3 subatomic particles: protons, neutrons, and electrons. Now, we also have a way of figuring out how many there are. Okay, so it relates to the periodic table. So if we take, for example, this element, lithium. All right, now we recapped the last day that lithium, Li, there's 2 numbers attached with lithium. There's a small number, 3, and there's a larger number, 7. I told you the last day that the 3 is what we call the atomic number. 7 is what we call the atomic mass. The atomic number tells us the number of protons an atom has. So lithium has the atomic number 3. That means it's got 1, 2, 3 protons. So 3 protons because the atomic number is 3. If I took beryllium, the atomic number is 4. That would mean it has 4 protons. If I took the number 5, boron, it's got an atomic number 5. That means it's got 5 protons, and so on. And it is this, the atomic number, that makes elements unique. So no 2 elements have the same atomic number because no 2 elements have the same number of protons. That's what makes them unique. Okay, so this atom of lithium has 3 protons. Now, atoms are neutrally charged overall, neutrally charged. Each proton has a charge of +1. So together, these 3 protons have a charge of +3. Now, atoms are neutrally charged overall. That means they have to have also a charge of -3 if they are going to be neutral, -3. So if it's an atom and it has a +3 charge, it must also have a -3 charge. So where do these come from? Well, these come from the electrons. So electrons are negatively charged. Negatively charged. Charged. And each electron has a -1 charge. So that means if I've got a -3 charge, I have to have 1, 2, 3 electrons. -1, -1, -1. So the atomic number lets me work out the number of protons. When I've got an atom, that means the number of electrons has to be equal to this. So if I've got 3 protons, I must have 3 electrons. Okay, the neutrons then, how do I work those out? Well, I work those out using the atomic mass. The atomic mass tells us the number of protons plus the number of neutrons, plus the neutrons. Now, for lithium, the atomic mass is equal to 7. So 7 is the number of protons plus the number of neutrons. Now, I already know that there's 3 protons. I've worked that out down here. So to get the number of neutrons, I take the atomic mass, I take away my number of protons, which was 3. And that means I've got 4 neutrons. Now that calculation isn't as important as this one. For this task, you need to know this. So that's why I was revising this, how to work out the number of protons and electrons. All right, let's go back to an example. Why are we talking about this? We're talking about moles. Let's say we got the question, how many electrons in 2 moles of beryllium, Be, sorry, what do I want it to do? Be atoms. Now, this time we've got 2 things. How many electrons in 2 moles of atoms? Okay. Well, if we think about it, the first thing we're going to need to do is say, well, how many does one atom have? How many electrons are in one atom? Well, beryllium has the symbol Be. So what I want you to do now is I want you to draw the atom for me. Oh, there's one more thing I need to tell you, sorry. You see these shells? These shells have rules. Fill it. The rules are, in the first energy level, this one here, first energy level, or first shell, you can hold a maximum of 2 electrons. Okay, and once that shell is filled, you must fill that shell before you're allowed to start in the second shell. So once you've put 2 electrons in the first shell, the second shell can hold 8 electrons, a maximum of 8 electrons. And the third shell can hold a maximum of 8 electrons, and so on. That's the first rule. Each shell has a maximum number. So we only need to worry about the first, second, and third here, really, okay? First shell is 2, second shell is 8, third shell is 8. That should be pretty much revision for you guys. That's the first rule. The second rule is that you must fill unempty shells before you move on to the next one. So you cannot put, for example, you can't do this. You can't put 1 in the first shell and then start filling the second shell. This would be wrong. You're not allowed to do that because you haven't filled the inside shell first. So you must fill the first shell. If you've got 3 electrons, that means you have to have 2 in the first shell and 1 in the second shell. You can't have 1 in the first shell and 2 in the second shell. Those are the main rules, okay? So what I want you guys to do is I want you guys to draw an atom of beryllium. Actually, I'm going to do this one with you. I'm going to draw an atom of beryllium with you. All right, so let's go to our periodic table and find our element beryllium. Well, here it is here. Beryllium is right here. It's got an atomic number of 4. That means it's got 4 protons. So number of protons is the atomic number of protons. And if it's got 4 protons, it has to have an equal number of electrons because this is an atom, okay? So in a beryllium atom, you have 4 electrons. So let's draw this. You've got 2 in the first shell like this. Then we draw a second shell, and we would draw 2 electrons in the second shell like that. So that is how we would draw an atom of beryllium. Now, before we worry about how many electrons are in 2 moles, we're going to practice some more of those drawing atoms. All right, so I've got some questions for you guys to practice now. So in your practice copies, you will need your periodic table. You're going to do questions 1 to 3 for me. Okay, so draw an atom of lithium, draw an atom of carbon, and draw an atom of oxygen. So pause the video and do those for me now, please. Okay, so this is what you should have. An atom of lithium has the symbol Li. That's the first thing. All right, let's get symbols for the other ones. The symbol for carbon is capital C, and the symbol for oxygen is capital O. So if you didn't know those and you didn't use those to work it out, you can go do that now. Pause the video again and go do that. Okay, so lithium, find it in the periodic table. Lithium, you will find, has an atomic number of 3. Lithium has an atomic number of 3. That means it's got 3 protons, and it's a lithium atom, so that means it's got 3 electrons. So here is the first 2 in the first shell or energy level. The rule was the first energy level can hold 2 electrons. So this energy level is full now. So for the third electron, I am going to draw a second energy level, and I'm going to put it here like that. So that is it complete. That's the atom of lithium. So this one atom of lithium has 3 electrons. This is an atom of carbon. Carbon has an atomic number of 6. That means it's got 6 protons, which means it's got 6 electrons. To draw this, I would put 2 electrons in the first shell. That shell is now full. I need to draw a second shell, and I'm allowed to put up to 8 in here. Well, I've only got 4 more left, so I can put them, I'm going to equally space them out like this, and that is my 6 electrons. So one atom of carbon has 1, 2, 3, 4, 5, 6 electrons. Now I'm just going to move my oxygen, so I'm going to make more space for it. Okay, and I'll go back to drawing. So this is my oxygen, O. Here is my first energy level. I've got, the oxygen has 8 electrons. Sorry, I should just write them above. 3 electrons for lithium, because the atomic number is 3. 6 electrons for carbon, because the atomic number is 6. And 8 electrons for oxygen, because the atomic number is 8. So well done if you got those bits right. And then we need to know that oxygen has 2 electrons in the first energy level, and it's got 6 more because it's got 8 altogether. Like this. It's got 6 in the second energy level. So altogether I should have 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, 8 electrons for oxygen. Good. So that was a little bit of practice drawing atomic structures for atoms. Now, why is that relevant? Well, we were asked the question, how many electrons in 2 moles of beryllium atoms? Well, as you see, one atom has 4 electrons. But we don't have one atom. We have 2 moles of beryllium atoms. Okay, so let's find out then how would we do that? Well, we know a 1 mole is 6.02 times 10 to the power of 23. Okay, so 2 moles of atoms are 6.02 times 10 to the 23. That's the 1 mole number. And we need to multiply that by 2 to get 2 moles. This gives us this number equals equals 1.204 times 10 to the 24 atoms. So this is how many atoms we have when we've got 2 moles of atoms. But I wanted to know how many electrons are in those 2 moles. So this is 2 moles of atoms. So I've got this many atoms, 1.204 times 10 to the power of 24. And each of those atoms has 4 electrons. So times 4 electrons. So when I do that on my calculator, stick that into my calculator now, and I get, you should be doing the same. So pause the video and try do that now, please. Okay, so you should only be watching if you have got an answer here. You should have this 4.816 times 10 to the power of 24 electrons. And that is quite challenging. That one is challenging, but it's still pretty basic maths. Okay, let's try another one together. How many electrons in 7 moles of nitrogen atoms? So it's the same as the one before. The first thing you've got to do is draw out the nitrogen atom. So pause the video, just down here, draw out the nitrogen atom. Okay, so this is what you should have. You should only be watching. If you've tried to draw it, you should have nitrogen has 7 electrons. 7 electrons. So it's got 2 in the first energy level. And in the second energy level, it has 5 more because it's got 7 altogether. So 1, 2, 3, 4, 5, 7 electrons altogether. Now, and we want to find 7 moles of nitrogen atoms. So let's find out how many atoms that is. Well, 1 mole So if we want to find 7 moles of nitrogen atoms, 1 mole is 6.02 times 10 to the power of 23 atoms. We don't have 1 mole, we want to find 7 moles, like that. Okay, so you put that in your calculator now and find how many atoms that is. Okay, this is what you should have. Equals 4.214 times 10 to the power of 24 atoms. That's how many atoms we have in 7 moles. 4.214 by 10 to the power of 24. Now, each one of those atoms, if we want to find electrons, each one of those atoms, we have all this amount of atoms, and every one of them has 7 electrons. So we're going to take that many atoms. We've got all of these atoms. Each one of them has 7 electrons. So that means we're going to have 7 times this amount, because this is the number of atoms. And every atom has 7 electrons. So all the atoms, we've got to multiply that by 7. So put that in your calculator now and see what you get. Okay, so you should only be playing if you've put it in your calculator and got the answer. If you haven't, pause and do it now, please. Okay, this is what you should have. 2.95 times 10 to the power of 25 electrons. Okay, I'm hoping you find this easy peasy. If you're struggling, then I suggest you go back and watch it again, because there's something small somewhere that you've missed. It's nothing major. It's nothing to be scared of, really. Okay, it's literally just probably something small that you've missed. All right, let's do some practice. I'm going to get you guys to do some practice on your own. Let's have a look at these. Okay, so number 4, how many electrons are in an atom of lithium? Oh, sorry, never mind. Oh yeah, that's the question is wrong. In a mole, say in a mole of atoms of lithium should be what that says there. Sorry about that now, just have to double check. Yeah, so how many electrons are in a mole of atoms of lithium? How many electrons are in 2 moles of carbon atoms? How many electrons are in half a mole of oxygen atoms? Pause the video, do those now, please. Okay, a reminder that if you've only found out if you've only found an atom of a mole of atoms of lithium, then you haven't actually figured out how many electrons that is yet. So a mole of atoms of lithium would be 6 by 10 to the 23 atoms. That's not the amount of electrons. So you've got to do something else with it to turn it into the amount of electrons. So don't forget to do that bit of the question. Okay, here are the answers coming up for number 4, 5, and 6. So 1.806 by 10 to the 24. That's the number of electrons. That should say electrons. All of these are working out the number of electrons. Electrons and electrons. So I want you to pause the video and either tick or fix them now. So those are the correct answers. If you haven't gotten correct, have a play around, just try them again and see if you can get the correct answer. If not, if there's a problem, do come back to me on it and I will explain it, what's going wrong. If you come back and leave a comment, or if you come back and speak to me personally, I will help you with it. All right, we're going to add one more layer to this, and that's we're going to put the skill we learned from last week into this, okay? And that is the idea that if we take something like H2O, what if I was asked how many atoms are in a mole of water molecules? Okay, there's 2 words important in this question. How many atoms are there, and how in these water molecules? Okay, So the first thing is it's really important to understand the difference between these two words. A molecule is where we've got a group of atoms chemically joined together. And we often show this using bonds like this. So H2O looks like this. We've got two oxygen atoms chemically combined, one oxygen atom chemically combined to two hydrogen atoms. We looked at this last week when we said that this water contained a hydrogen, another hydrogen, and an oxygen. This is a water molecule. A molecule is a group of atoms chemically joined together or bonded together. That is a molecule. Whereas an atom are the individual circles. So an atom is just one of these circles. So first of all, how many atoms are there in a mole of water molecules? Well, first of all, we look at the molecule and we find out that each water molecule has 1, 2, 3 atoms in. This is like we learned how to do this guy last week. What if we did, say, carbon dioxide, CO2? Well, this is one carbon atom and 1, 2 oxygen atoms. So a carbon dioxide molecule, this is a molecule, is made of 3 atoms. What about this one here? You do this one for me again. So if we do NO3. All right, you do that one for me, please. Pause the video and do it now. Okay, so this is a nitrate molecule, and it's got a nitrogen and 1, 2, 3 oxygens, altogether 4 atoms. This one, altogether 3 atoms. This one, 3 atoms. Okay, so how many atoms are there in a mole of water molecules? Well, first of all, 1 mole of water molecules is 6.02 times 10 to the 23. So this is water molecules. We have 1 mole of them. So we have this many. And we want to know how many atoms there are. Well, in each water molecule, there are 3 atoms. So to get the number of atoms here, I would take my mole number and multiply it by 3. Okay, and what I would get there is I would get 1.806 times 10 to the 24. So that's what I would get there. So we're going to use that skill now. You guys are going to practice doing some of those. So let's go up and have a look over here. All right, so question 1, 2, 3, and 1, 2, and 3 should be pretty straightforward. I've given you the formulas so you can work out how many atoms there are. Those are pretty straightforward, just like what I've just done. The last one is a real challenge, okay? So if you're well able to do this, if you've been doing all of these, the last one's going to challenge you because you're asked, you've given a molecule, carbon dioxide, and you're asked how many electrons are in it. So the first thing you're going to have to do is work out how many molecules is a mole of carbon dioxide molecules. Then you're going to have to find out how many atoms are in it. Then you're going to have to work out how many electrons are in all those atoms. Okay, so I'm not going to spend too long doing that, but this is a challenge. If you're finding this very easy, then this one might push you a little bit more. Okay, all right, so let's pause the video and try those questions 1 to 4 now. Okay, so you're only listening to my voice if you've done questions 1 to 4. Here are the answers coming up. Okay, so question 1, 2, 3. I'm hoping they're pretty straightforward. If they are not, then go back and watch the bit that I just did. Watch it again to work out the number of atoms in a given number of molecules. What about this one? All right, I am going to show you how this one was done. Okay, so we have 1 mole of CO2 molecules, and we want to know how many electrons are in that. Well, 1 mole of CO2 molecules is 6.02 times 10 to the 23. Okay. That's in 1 mole of molecules. Now, if I take carbon dioxide, let's find out how many electrons are in here. I've got a carbon, and I've got an oxygen, and I've got an oxygen. Now, I've got carbon, and I've got 2 oxygens. If I was to take these then and say, how many electrons do they have? Well, carbon has 6 electrons. I know this because the atomic number is 6. Oxygen has 8 electrons. And this oxygen has 8 electrons. So altogether, this molecule has 3 atoms, and altogether it has 8 plus 8 plus 6, 22 electrons. So these 3 atoms between them have 22 electrons. Now, that may have triggered something in your head if you haven't already started. Now that you know that, you may be able to pause the video and finish it off. Okay, if you can finish it off, you know now and you figured out what the little bit was, pause the video and finish it ahead of me. It's better if you can stay ahead of me. Okay, so you should only be watching if you've tried to have a go at finishing that off by yourself. Okay, so it's, we have this many molecules, 1 mole of them, and each of these molecules, 6.02 by 10 to the 23, every single one of them contains 22 electrons. So when we do that sum there, that will give us this number up here, a really, really big number, 3.9732 by 10 to the 25. Guys, if you did that by yourselves, that is brilliant. If you didn't, but you were able to do the rest, I don't want you to worry too much about that one. That one was pretty tricky, to be fair. I just wanted to see if I could push people a little bit further. If you were able to do the rest, then I'm happy enough. If you're not able to do them, then I suggest you're going to have to go back and watch the video again, okay? And really, we don't want to move on to the next bit until you understand this, okay? All right, guys, do leave a comment down below if you need any help, or if you found this useful. If you found it more useful than just reading something and figuring it out, then please do leave a comment below. It really helps the channel, and it helps to tell other people why they should stop and watch. If you found it useful, you can also leave me a like, thumbs up. And if you didn't find it useful, leave a thumbs down. Okay, anything just to let me know that you guys are watching and finding it useful. Okay, thanks guys, I'll see you in the next video.